Hi, I'm Dick Seitz. Welcome to the Software Screw-Up series based on my book Understanding Software Dynamics. Today's episode 8 is about deep algorithm changes, all taken from the index for screw-up entry. So it's difficult to learn much about a person from a flat profile. So it is with PC sampling execution profiles or flame graphs of CPU-bound code. If you have a PC sampling execution profile that has peaks, that's useful for improving average code performance because it pays to work on improving any of the heavily used code. But once you arrive at a fairly flat profile, it's time to change strategy. If an execution profile is fairly flat, but the average execution time is still too long, you need deeper algorithm changes to do less total work, or you need to change your performance expectations. Here's an example from the 1950s. But you can't look up all those license numbers in time, Drake objected. We don't have to, Paul. We merely arrange a list and look for duplications. This is from Perry Mason, The Case of the Angry Mourner. So Paul Drake was going to match license plate numbers in two lists by comparing each number in one list with each of the numbers in the other list, an N by M algorithm. Perry Mason suggests instead forming a sorted list and then looking for duplicates. Of course, with a decent sorting algorithm, this will be an n plus m times log of n plus m algorithm, much faster if m and n are big. That was the 1950s. Today, hashing the numbers into a table that's maybe twice the size of the total number of items and looking for an existing number in the table is a linear algorithm, so much faster. And alternately, something like Bloom filters can be used, also a linear approach. The point is that once edits of heavily used CPU-bound code produce an execution profile that's fairly flat, but you still want better performance, it's time to rethink the algorithms used or rethink the performance goals. Completely different considerations apply to non-CPU-bound code that's waiting on something. So we'll see some examples of that in other videos in this series. Thank you for watching Understanding Software Dynamics, the Software Screw-Up series. Take care.